All right, problems 19 through 21. We have this equation, k of x equals 2x minus 2 divided by x squared plus 2x minus 3. With these rational functions, the first thing you want to do for these is factor the top and the bottom. Just factor as much out of those as you can. And so for this one, we're going to get, we can factor a 2 out of the top. So we're going to get 2 times x minus 1. And then on the bottom, we can factor this to, we need two numbers that multiply to negative 3 and add to 2. So that's going to be positive 3 and negative 1. So we get x minus 1 times x plus 3. Okay, and then notice that here we've got an x minus 1 on the top and on the bottom, so we can eliminate those. Those are going to divide to 1. All right, so now let's jump into the problems. Number 19 says find the vertical asymptote. The vertical asymptote from in these rational functions comes from the fact that we can't divide by 0. And the closer we get to dividing by 0, the function's going to shoot off toward infinity or toward negative infinity. Toward infinity on one side, toward negative infinity on the other side. And so we get that asymptote happening there. So if in order for us to be dividing by 0 here, x plus 3 would have to equal 0. So we're going to set that equal to 0. X plus 3 equals 0. So x equals negative 3. And that's going to be our vertical asymptote, is x equals negative 3. So we have A for number 19. For number 20, it asked us to find the horizontal asymptote. So three things with horizontal asymptote. If you have a situation like here where the degree of the numerator is smaller than the degree of the denominator, then this is going to, the horizontal asymptote is going to be y equals 0. Essentially what's happening here is we want to figure out what happens when we plug in a really big number for x. And if we plugged in a big number for x, then the top is going to be a big number, but the bottom is going to be a much bigger number because we're squaring on the bottom. So if the degree on the bottom is larger than the degree on the top, then it's going to tend toward 0. And so that's our answer for number 20. The horizontal asymptote is going to be y equals 0. If the degrees were the same, then we would ignore everything except for the leading coefficients, and that would be our answer. If the degree of the top were small or were larger than the degree on the bottom, then we wouldn't have a horizontal asymptote. In that case, we may have a slant asymptote, but no horizontal asymptote. So for number 20, this is getting closer to y equals 0. All right, and then 21, find any removable discontinuities or holes. The holes are going to come where we would get 0 over 0 if we plugged in that number. So back here when we were able to cancel out this x minus 1 on the top and the bottom, whatever you canceled out there, that is going to be, that's going to give you your 0. So x minus 1, if x minus 1 equals 0, then x equals 1. So that is going to be your hole at x equals 1. And that's B for number 21. So just remember on these, factor it. The vertical asymptote is set to what's remaining in the denominator equal to 0. That gives you your vertical asymptote. Whatever you canceled out, if you set that equal to 0, that's going to give you your hole.